Okay, let's look at a question from using trigonometric ratios, question 17, page 439. Here is a mast. It's 12 meters high. It casts the sun shining on the mast casts a shadow that's 30 meters long. We're asked to find x. Now we'll be meeting in a while. X is actually known as the angle of elevation. Okay, so we can just work with the ratio tan because we know the opposite side to x and we know the adjacent. So it's 12 over 30. Tan x is 12 over 30, so x must be equal to the tan inverse of 12 over 30, 21.8 degrees. Now, let's look at another example here. Solving right-angled triangles. Find the lengths of the sides marked x and y in the given triangle. Give your answers correct one decimal place. Okay, so we have 35-degree angle here, and the sine of 35 degrees is equal to its opposite, which is y, over the hypotenuse, which is 12. So sine of 35 is equal to y over 12. That must mean that sine, if we multiply both sides by 12, we end up with 12 times sine 35 there, and if we had a 12 there, it would just cancel. Okay, so sine of 35 times 12 is equal to y, so y is equal to 9.8. And here is a question from, oh actually, sorry, do I have to find x and y there? I think we do. Yeah, okay, so to find x then, we just say that cos of 35 is its adjacent over the hypotenuse. So cos of 35 is equal to x over 12. That must mean that 12 times cos 35 is x, so x is 6.9. And here is question 12 on page 443. So we're given this triangle here, PQRS, and we're asked to find the length of the side PS. Okay, so how do we do that? Well, we just simply take this right angled triangle here. That's obviously the hypotenuse. So PS squared is equal to the sum of the other two sides squared, 7.5 plus 3.2 all squared. PS is equal to 8.15. And then we're asked to find the angle SRQ. Remember, you find S, you look for R, you go back to Q, and SRQ is the angle in the middle, or it's the angle at R. Okay? So we can say, we know it's opposite and adjacent, so we can say the tan of that angle is equal to the opposite over the adjacent. So the angle must be equal to the tan inverse of that, is equal to 38.65 degrees. Now here's another example down here. We have a right angled triangle with an angle at C. We know it's opposite and it's adjacent. So find the angle ACB. Find this angle in here at C. Okay? So the tan of this angle is equal to 9 over 13. So the angle must be equal to the tan inverse of 9 over 13. The angle is equal to 35 degrees. Now, using trigonometry and the ratios associated with it to solve real life problems. So let's just have a look at this first of all, just bear with me. So we'll just mention the angle of elevation and the angle of depression. Okay, so if someone is standing on the ground, okay, and they're looking along in a horizontal line of sight, and then a plane flies overhead and they suddenly look up towards the plane. Well, the angle that's generated between the horizontal line of sight and this new line of sight that's looking up at an object is known as the angle of elevation. Okay? And if someone was looking, standing on a cliff, say, and looking straight ahead, and then they noticed a boat down in the sea, then this angle looking between the horizontal downwards towards a line of sight is known as the angle of depression. Now, here's an example. Alan stands at A, okay, directly under the end of a crane. Here's our crane. From A, he walks 10 meters to B, okay, At B, he measures the angle of elevation. So he measures the angle of elevation up to the end of the crane. So we imagine that he's looking up. It doesn't have to always be looking, but that's the angle of elevation from this horizontal upwards, okay, to the crane, and he measures that at 73 degrees. How high is the crane? What's this height here? So you can see that the story is generated a right angle triangle. So the tan of 73 is equal to its opposite h. And it's not the hypotenuse, remember, this is the hypotenuse. This is h for height, okay? Tan of 73 is equal to h over 10, here's our 10 here, is equal to its opposite over its adjacent. So that must mean that 10 times tan of 73 is equal to 32.7 metres. Now we're just going to finish by considering the angles 30 degrees, 45 degrees and 60 degrees, and just to note that they have particular ratios that are fixed and are in the log tables, okay? So the 45 degree angle, we can generate 45 degree angles by creating this isosceles triangle of lengths of side equal to 1 unit. Okay, so these two sides are equal. This is 90 degrees, and the angles opposite the equal sides are equal, so there's 90 degrees going a begging if you think that 180 minus this 90 is 90 left, divided by 2, so these two are 45 degrees. Okay, and because these are 45 degrees, this hypotenuse, because these are 1 unit in length, the hypotenuse is the square root of 1 squared plus 1 squared. The hypotenuse is actually equal to square root of 2. So the sine of 45 is equal to the opposite over the hypotenuse. For any of those 45s, it's 1 over root 2. The cos of 45 is equal to its adjacent, any adjacent there, which is 1 over the hypotenuse is root 2. And the tan of 45 is equal to 1. Is equal to the opposite over the adjacent. 1 over 1 is 1, or opposite over adjacent 1 over 1 is 1. Okay? And for the angles 30 degrees and 60 degrees, we can generate these angles again by drawing simply a right angle triangle of base length 1 and height root 3, which generates a hypotenuse of 2, and this gives us a 60 degree angle and a 30 degree angle. And from this triangle, we can see that the sine of 60 is equal to the opposite over the hypotenuse, root 3 over 2. Cos of 60 is a half, tan of 60 is root 3. And the sine of 30 then is its opposite, 1 over the hypotenuse is 2. The cos of 30 is root 3 over 2. And the tan of 30 degrees is 1 over root 3. Now, just so you know, these are available and are fixed. They're available on page 13 of your log tables, and we'll see how we can use these to perform calculations with right angle triangles without using a calculator. Okay, so here's an example. Find the values of x and y in the given right angle triangle. So we've an angle of that's 60 degrees in here, of x, y, and a base of 4. So the cos of 60 is equal to its adjacent over the hypotenuse is 4 over y. But we know from the log tables or from the previous part of the video that cos of 60 is actually a half. So 4 over y is equal to half, so 2 4s are 8 times 1 by y is equal to 8. And to find x then, we're not using a calculator here now, we're just using the ratios in the log tables, fixed ratio of cos 60. X over 4, the opposite over the adjacent, x over 4 is equal to tan of 60. But tan of 60 is actually root 3 over 1. So x is equal to 4 times root 3, just cross multiply. Okay? And if we look at, no, we're saying something there. Not yet, no, okay. So look at question 7 here now. It's from the book. Just find the sine of 60 degrees and just look at the log tables is root 3 over 2. Question 11 then. Show that 1 minus sine squared 30 equals cos squared 30. Okay. Well, before we do that, let's just look at this first. Okay. Sine squared 60 is really mathematically the sine of 60 squared. And sine of 60 from the log tables is root 3 over 2. And that's all squared. Root 3 by root 3 is 3, 2 by 2 is 4, is 3 over 4. So that's why we say here that sine squared 30 is actually the sine of 30, which is a half all squared, and that's equal to the cos of 30, which is root 3 over 2 from the log tables, all squared. A half, that's 1 minus a half by a half equals 3 over 4. Let's see, does it? So a half times a half, 1 by 1 is 1, 2 by 2 is 4, so it's 1 minus a quarter equals 3 quarters. Yes, it does. 3 quarters equals 3 quarters. And let's look at question 14. Find x, y, and z without using a calculator. Okay, so here is our right angle triangle, two right angle triangles, but let's find y first, okay? So we have the angle of 30 degrees, so we should know when we see that, or 60, that we can look at our log tables for the ratio, page 13. But the sine of 30 is equal to its opposite over the hypotenuse, y over 8. But that's equal to a half, is equal to y over 8. So that means 2 times y, if we cross multiply, is equal to 1 times 8, so y is equal to 4. Okay, so now we know that y is equal to 4. And so now we can say that the sine of 60 then on this side, is we're looking to find z now here. The sine of 60 is equal to y over z. Okay, is equal to its opposite over the hypotenuse for this right angle triangle here. So sine of 60 is equal to 4 over z, but we know the sine of 60 is root 3 over 2 is equal to 4 over z, so that means that z is equal to 8 divided by root 3. And then to find x finally here, we just said the cos of 30, the cos of this is equal to its adjacent, which is x over the hypotenuse, which is 8. So cos of 30 from the log tables is root 3 over 2, is equal to x over 8. That means 8 times root 3 divided by 2 is equal to x, and that's the same as 4 times root 3.